Hello, students. I remain your lecturer, Dr. Jaco. Today, we are going to continue with our data mining and big data analysis class, lecture 1, part 3. Today, we are going to explore knowledge discovering processes, cleaning, integration, and selection. Knowledge discovering in data mining is just all the pre-processing stages of your machine learning or data mining modeling. The first thing one need to do, or the first stage of the knowledge discovering process, is data cleaning. Data cleaning is just removing noise and inconsistencies in your data. For instance, I want to show you some of the model I did and how a typical example of how you can clean up your data. So when you want to train a model, the first thing process is collecting your data. When you have collected your data set, you have to first of all clean it up. I'm using Jupyter Notebook as I've shown you in the Python class how you can use machine learning. I have my folder where I have all my files in desktop. Machine learning, these are all my machine learning projects. You can see all the previous projects I've done here. I open up one here to show you how data is cleaned. Here you have import OS. I've told you that Python is a powerful programming language with so many libraries. You have to import the library instead of writing everything from scratch. This is simple explanation of what the library can do. In Python class, if you go through the book you have in my Python Mastering for Data Analysis and Machine Learning, you will see that there are different ways you can put a comment. In Python, you use this triple triple invited commas to have so many lines of comment. You can see that it's in red. If it's a single line comment, you use hash. So this will explain, you just use this to explain a little of what this import OS is doing. But here our interest is to use the dot get CWD part of it. This is a function. This is a function that can be gotten from this OS. You see that simply import OS is a Python statement that allows you to use OS operating system module. So in Python library, many libraries have been packed in module. Inside the module, you see classes. Within the class, you have so many methods. So once you import the module, it will allow you to use the classes and the method. So here we are using the getWD method to get the actual directory where your folder or your directory is. The folder is a directory. Here we call this current directory equal to os.getCWD. It will get you, you print it out, it will show you exactly where your directory is. This is a variable name, if you all know, you can change it. I can decide to use it as directory equal to this and still get the same function there. So it will help you to get the current directory. I call it current directory so that you will be able to know that I'm trying to retrieve the current directory. So now what it does is I have shown you that look at exactly where your directory is, so that when you are using it inside the code, you actually map it to that actual directory. You can see I have a data set and downloaded for cargo housing. I name it housing.cs. So I install it inside this my machine learning folder. I store it inside house prediction house price prediction folder, and I put my data set inside there. So this is a variable where I map. If you look at it, the directory you check with this os.getCwd gives you a backspace, gives you the directory in backspace, but when you're writing it in your program, you have to change it to forward slash. You have to change it to forward slash. You see? Then this will enable you to create use pandas. Pandas is a data manipulation library that will enable you to read your file. You have to read it from this part. So when you read it and show, you either print it this way or just use df if it's Jupyter Notebook, just calling the variable with display. So you can see that look at our data set. If you look at this data set, you see that you have this classification, yes and no. This is a classification problem, yes and no. So this, if you look at it, it retrieves all the data from 0 to it has a total of 545 rows. So here I give dot dot because this is not if it's going to display here to cover everything. So you can also run a code to display the first 5 data by using this. So what I'm trying to show you here is that you know that this is in categorical form. You can encode it. If this database is displayed or you open it in Excel, you discover that there are also some missing data. So Python has libraries. For instance, these are different libraries from sklearn, scikit-learn, that will enable you to import modules and other pre-processing method that will enable you to clean your data. So if you go down, you will see where I was able to remove all data that are missing data. So you use all data. Here, handling missing data. So we use the fill method to remove filling missing value with forward fill method. So there's different methods that you can also use the mean or the mode of the data. You can use a function to get the mean on the mode and also use it to fill up all those missing data, or you just simply use the fill forward method. So this is the method that is called from the pandas. If you look at from the beginning, you see where I imported pandas. You go and study all the things that pandas are used for. At the beginning here, I explained it. So import pandas IP, this is an alias. You see, pandas is a library, a powerful data manipulation and analysis tool for Python. So you use it to call upon different pre-processing methods. So that is what you mean by data cleaning. When you go down here, you see where I encoded this yes and no to 0 and 1. You can see this data encoding method. See, we use this label encoder and a label encoder function to change all these yes and no into 0 and 1. You can see the former data and the new data when it is changing is encoded to 0 and 1. So these are the pre-processing method. Before you can train your method, you must clean your data very, very well. So that is the first stage of a knowledge discovering process. So we have another knowledge discovery process that is called data integration, merging data from multiple sources. So you are going to see in one of our projects whereby we have two data sources that we want to use in our modeling. You see how you can also use some the Python libraries and functions to merge two data sources. So this involves combining data from different sources. So these are the tasks that are involved. You have to check out how is the schema matching, aligning different data structure. That is matching maybe a customer ID in one database with another customer ID in another database. You also remove a handle redundancies, remove duplicate record from the merge data set. The particular field or column that are repeated, you have to clean it up. So data fusion, combining multiple data points into a single record. Real-time example is in healthcare, integrating patient data from different hospital or medical record into a centralized electronic health system. So we also have data transformation, converting data into a suitable format. So the example, you have normalization, maybe scaling numerical value to a standard range. Example 0 to 1. You can have a particular data format, but the other data field are not in the same scale. You need to normalize it for it. There are different imputation methods that can be used in scaling your data to be normal. So pattern you have an example here in machine learning, converting high, medium, and low level into numerical value 3, 2, 1. This is a typical example. We also have pattern evaluation, validating and interpreting discovered pattern. Pattern evaluation is the process of validating, refining, and interpreting the pattern discovered during machine learning data mining to ensure that they are meaningful and actionable. So have statistical validation, checking confidence level, performing metrics, using accuracy, precision, and recall. So when you go to these are model, you go down and see where I validated the data. After you have to check for null. You can see this is where check for missing value. You use missing value equal to data dot is not dot sum. You will have to get the sum up of the data set that is missing. You can see that in this it shows that there is no missing data. So you have to go down and see other pre-processing method that takes place here. So you can also what we call the feature engineering. Feature engineering is that it's not all the fields, that you might need in your data set. You have to select the data set that you need. So when you are sure that your data has been properly normalized, you can go ahead to use it to train your model. So you can see that after cleaning up, you can decide to push it down to a new table. You see that these are push it down to a new table. Now I'm dealing with a new table that is well cleaned. So once you are done, you go down to where, yes, you see, in this aspect, we start training the model. You start training the model from sklearn example. We use random forest to train this model. So when you train the model, you have to evaluate it. I have to show you the example of evaluation method that you can use to evaluate all your trained data. So you go down, you see here the different evaluation method that is used. You see, so you can see here the different mean square error. You can use the mean square error is an evaluation matrix that is used for categorical classification problems. So you can use mean square error for decision tree. It give you this value, root, mean square. You have to study all this is, and when it is 0 or less than 0 or more than 0, what does it show? Does it say is it really accurate, or it has an outlier, or it has a problem? So this is an example of how a model can be validated. So that is that for pattern evaluation or validation. So this is where we classify. Also, data visualization. You can visualize your data. You visualize your data. Here we also did a visualization. Here we visualize. Here we try to visualize all the models based on the evaluation matrix. You can see the comparison of arrow score matrix evaluation for all the machine learning model. This is a KNNS model, but this is a supervised vector machine. This is a lasso regression. This is linear regression. This is random forest. So this is how you visualize your data. Uh, Python has a whole lot of libraries that you can use for visualization from this matplotlib. Matplotlib and some other visualization library. There are a lot of them we are going to explore. Here you also visualize the actual predicted price. You also visualize it here. So that is all you need to do in data pre-processing. First of all, clean up your data before you can use it to do, you can apply any machine learning techniques to it. So this is a clear summary of knowledge discovery process, cleaning, integration, selection, stages, purpose, key techniques, and example. So data cleaning, the things that is done there, the key techniques that you use, imputation, duplication, outlier, detection, data selection, choosing relevant data for analysis, data integration, merging. So this is a summary of all you need to do. So the next thing we look at is the tools that we can use to apply all these data mining techniques, reprocessing techniques. We have explained that you have Weka, RapidMiner, Python library like scikit-learn or sklearn in short, Pandas, NumPy, SciPy, Syria, MATLAB, so many of them. Um, so many of them. Weka is a Weka2 environment for knowledge analysis. It's an open source machine learning software developed at the University of Waikato, New Zealand. It provides a graphic user interface and command line interface for performing various data mining tasks, such as classification, clustering, regression, and association rule. We also have RapidMiner. We say that in this class we are going to use, we also have KNIME. We say that here we are going to use our Python programming because it enables us to do a lot of dynamic analysis. It has a huge library. It has a huge library like this sklearn it has been there as far back as 2017. As far as 2017 has been in use as far back as 2017. So these are the different comparison of this data mining tool. You can see that the strength, the Weka is best for beginners. Python is developers and the researchers. Arrow is statistical analysis. I have told you that the difference between Python and Arrow is purely statistical programming language for statistical analysis. But the good about Python is that you use it for both general programming language. It's a general programming language. You can also use it for web development. You also use it for data analysis. You use it for machine learning, engineering. And when you finish training your model and deploy it, uh, um, deploy it, you can also use Python Django to deploy it in real time. So automate it so that it can be used in the different web applications to perform automation, because what we are saying about machine learning is trying to automate those decision making process or predictive processes. So a lot of things can be used. Python is there for you to do not only analyzing the data, you can also use it to automate it in real time. So that is how where it seed R in R can be used in analysis, but it cannot be used as web scripting or standalone development as used for Python. So that's why we choose Python in this class, because it's very dynamic and it can enable us to do a lot of things. Thanks for listening.